Lesson 28. This is solving equations with variables on both sides. So it's basically the same kind of concept that we've been doing. You're still going to simplify as much as you can before, get all your variables on one side, all your regular numbers on the other side, and then solve down. It just may include one or two more steps than we've been doing. So go to example 1. We are going to start there. So we have 6x equals 4x minus 10. Now this is easy, and it says we're going to justify each step as we go. So I set up a 2-column little proof style deal here. So start out equation, I have 6x and I have 4x minus 10. Now reminder, I want to get all the variables on one side. So which one should I move? 4, right? Because the number over here is already going to be by itself if I move that 4. I wouldn't want to move my 6 and then move my 10. That would just make my life a little more difficult than I want it to be. It's adding steps that I don't need. So I'm going to subtract 4x. I'm going to subtract 4x. So this is just the same as combining like terms. When I subtract 4x, I get 0 x's, so it goes away. Here I have 6x minus 4x's, which leaves me with 2 x's. Don't forget to drop down that equal sign. And then over here, don't forget to drop down your negative. Okay, it's that whole little bit there. Don't forget that negative. And then the next step will be the same as what we've been doing before, but I need to justify what I did. So the justification for this would still be, because I subtracted, it's just subtraction, property of equality. Property of equality. Next one, how am I going to get rid of this 2? Divide it by 2. So that goes away. X then will equal negative, don't forget about that, negative 5. Okay? So my justification for this step will be division, property of equality. And then obviously my last step was just simplifying. I didn't do anything special there. I just simplified negative 10 divided by 2. Okay, any questions thus far? Okay, it's going to build rather quickly, and we're going to add extra steps. So make sure that you are verbal about your confusions if you have any. Example 2. 5, open parenthesis, 2x plus 4, close parenthesis, minus 2x equals 6 plus 2, open parenthesis, 3x plus 12. Let me give you all a second to catch up just in case. And I did not leave enough room for me to do my 2-column proof. There we go. Okay, I'm going to end up writing really small on that right-hand side, so try to listen as I say it. That way I don't lose ya. Is anybody still writing? Okay, step 1. I have to get this in the simplest form possible before I start trying to combine like terms. So I need to distribute. I need to get rid of my parentheses. Okay, so in my simplification process, I'm just following order of operations the best I can. Okay, so simplification says I need to distribute this 5, so I'm going to distribute it. 5 times 2x is 10x. 5 times 4 is 20. Okay, and then this negative 2x or the minus 2x just drops down. Nothing special there. Next, I drop down that 6, nothing special there. Plus, now I have to distribute this 2. So 2 multiplied by 3x gives me 6x. And 2 multiplied by 12 gives me 24. Don't forget to drop down your operator. The most common one that y'all guys will miss is if this is a minus, then you'll forget to drop down the minus and you'll make it positive or something of that nature. So make sure that you drop down whatever the operation is. And if these are negative, then the negative would get distributed with it. So be careful of that as well. Okay, I've got rid of that. I've simplified by using what property? A distributive property. Okay, that's a distributive property. I just can't write it all the way out. Okay, so that's one line. The next line, I have to start combining like terms. Now, I can only combine like terms on each side. So I'm going to combine the left side of my equation first, and then I'll combine the right side of my equation. Okay, so over here I have a negative 2x and a positive 10x. So I'm going to combine those to get a positive 8x, and then just drop down my 20 because there's nothing that went with it. Okay, have my equal sign again. Over here I have a 6 and a 24 that needs to be combined, and then I just need to drop down my 6x. So I have 6x and plus 30 when I combine those two things. Okay, so what is that called? Combining like terms. So that's combine like terms. It's another step in our distributing process. Now, what allows me to just randomly move these things around? What property lets me? What allows me to commute, right? So commute means move or go from one place to another. If I commute to work, I drive. So I move. So this is the commutative property that allows me to move those. And then I reassociate them and put them together. And that's what allows me to do that. In simple terms, I just combine like terms. Okay? But in reality, what we're using is the commutative and the associative property. You always just don't realize it, or we don't call it that all the time. Next, I need to get all of my variables on one side and all my numbers on the other. So which one of my variables do I want to move? 6x, right? So I'd want to move my 6x. Why am I moving my 6x, Maddie? To get it on the I don't know? That was a good answer. Well, you're giving me the right answer, but I need a justification as to why. Why would I not move the 8? If I move the 8, what am I going to end up with? A negative. I don't like negatives. I'm a rather positive person, so I want to deal with the positive things. That's why I would move it. So what property allows me to do that? Subtraction property of equality, POE. Okay. Next step, I need to get all of my regular numbers to one side. So which one do I move? The what? The 20, right? I'm going to move the 20 because if I moved the 30, then I'd have everything on one side and nothing on the other side, and then I'd have to add another step in, and I don't want to have to do that. Okay? So to eliminate having to do another step, I will subtract my 20, which is over here bugging my 2x. 30 minus 20 is 10. And same property allows me to do that. Again, the subtraction property of equality. I'm just going to put little quotations. Now, next thing I need to do, get the x by itself. What do I need to do? Divide by 2. That is the division property of equality. So I'm left with x equaling 5, and that's just simplify at the end. Okay, so x equals 5. I heard it. Any questions? Okay, also, when you want to check these, which is often, especially since we have calculators that make it so easy, I just take this x and I plug it in everywhere I see an x. Okay, into my original equation. Okay, always plug it into your original equation. Right. Any questions before we move on? Example 3 then. Example 3 says 10 minus 6x equals negative 2, open parentheses, 3x minus 5, close parentheses. Okay, I'm not going to tell you them out to the side, but I'm still going to ask you what properties we're using. Alright, so first thing I need to do is what? I need to distribute that negative 2, right? So I'm just going to rewrite my left side and start my distribution. I'm distributing the negative 2. So it's negative 2 times 3x is negative 6x. And then negative 2 distributed to a negative 5 will give me a positive 10. Okay? Does anybody notice anything already? Okay. Looks the same on both sides. So let's follow this through and see what ends up happening. Okay, of course I want all of my variables on one side and all my numbers on the other, right? So let's see what we can do. I'm going to subtract 10 from both sides to get all of my numbers on one side. 10 minus 10 is 0, and then again 10 minus 10 is 0. So those just went away. I have negative 6x equal to negative 6x. So if it wasn't obvious to you that they were the same before, it should be now. But in order to solve this, I'd want to move all my variables to one side, right? So I'd add 6x and add 6x using the addition property of equality. And then negative 6x plus positive 6x is 0x's. And then negative 6x plus positive 6x is, again, 0x's. So I get something that's like 0 equals 0. And this is what it'll turn out to be all the way down if you always finish it. Okay? If you do all of the steps to get to what you're trying to get to. But the point is, at every single step here, I saw something that was definitely true, right? 10 minus 6x is the same as negative 6 plus 10. And then over here I saw negative 6x is the same as negative 6x. And now I'm at my very final step, 0 is the same as 0. Is that true or false? It's true. When is it true? Resounding always should be coming out of your mouth. So it's always true. 0 is always equal to 0 no matter how we try to word it, right? 0 is always 0. Then I had a college professor that told me that wasn't true. So 0 is always equal to 0. That is true. If I end up with something that is true, if I ever end up with something that is true, whether it be 10 equals 10, negative 6x equals negative 6x, whatever it is, if I end up with something that is true, my answer is infinitely many solutions. So all that really means, since it's infinitely many solutions, means I can plug any number in for x and it will always give me something that is correct. If I plugged in 0, it would give me something that is right. If I plugged in 2, it would give me something that is correct. Okay? So it says basically all of the answers that you can possibly think of that are real numbers will be correct. Okay? So infinitely many solutions. So if it's, when it's true, it's infinitely many solutions, what do you think is going to happen if you get something that's wrong, like 10 equals 0? It's going to be false, obviously. But how many solutions do you think you'll have? None. Okay, so 7x, next example, part B. 7x minus 2 equals 9x minus 5 minus 2x. Okay, before I start this, I need to combine like terms. Over here, I have nothing to combine, so I'm just going to rewrite it down in the next step. Over here, I have a 9x, and I have a negative 2x, so I can combine those to be a 7x minus 5. Now, some of you may have already noticed that something's going to happen here, because my next step is I'm going to move all my variables to one side. So minus 7x, using the subtraction property of equality, I get both of those to cancel, so negative 2 equals negative 5. Is that true or false? Obviously false, right? So what does this mean about how many solutions I have? No solutions. So in our repertoire, we now have seen infinitely many solutions, we have seen no solutions, and we have seen one solution. Okay? So those are your three options. You're going to have either an answer, which is like x equals something, or y equals something, or some variable equals some number. Okay? Or you're going to have something that ends up being true always, so that'll be infinitely many solutions, or not true ever, and that will be no solution. Okay? Any questions on that stuff? Okay. Just be careful when you get to the bottom and you go, oh, I don't think I did this correct. Remember that we have these options of no solution and infinitely many solutions. Okay, before we move on, I'm going to give you the biggest mistake that y'all guys will make on this. You will try to subtract something, like for example, let's say we did subtract 7x. You will try to do it to both sides, but the problem is you'll end up subtracting 7x from everything. Okay, so be sure you can only combine like terms. Okay, so if there's a 7x here and a 7x here, I have to line up my x's. I have to only combine things with the same last name. I cannot combine a regular number and a variable number. Okay. Example 4. This is the application of telephone rates. This is how they used to charge for telephones, like cell phones. They don't really do that anymore. Telephone company charges $18.95 per month. For local calls and 4 cents by the minute, so 4 cents per minute for long distance calls. So this is telephone company A. That's the group A. So I'm guessing they're giving us telephone company B. So let's see what they charge. Telephone company B charges $21.95 a month. And 2 cents per minute on calls. For long distance calls, for what number of minutes and long distance calls per month is the cost of the plans the same? So, back before we had cell phones, we got charged for long distance. Now we only get charged for calling out of country. So this is a little bit of an outdated problem, but let's just deal with it as if this were out of country rather than long distance. Okay, so going from here, I want to remind you of what this should end up looking like. Y equals mx plus b. This is slope-intercept form. Slope is your rate of change. And b is your initial cost. Okay, this would normally be your slope and your y-intercept. In this reference frame of mind, we're going to say it's rate of change and initial cost. Those are the exact same kind of things. So for company A, I'm going to write an equation that will give me the total for company A. So y equals, what is my rate of change for company A? 0.04, because they're charging me by the minute. I only want to know for 1 month. So it's 0.04 multiplied by x. What does x stand for? If it's 4 cents per minute, what does x stand for? Minutes, right? So I might need to note that up top. X is minutes of long distance usage, right? Plus, I'm just dropping that down, my initial cost. What was my initial cost for the month? $18.95. So that's for company A. I'm just going to write a little side note, make sure I know that. Okay. For company B, same concept. What is my rate of change? 0.02 x, x still standing for minutes, plus my initial cost of $21.95. Okay, so now I have 2 equations. Now I'm going to reread the last part of the problem because we got to figure out. We decided x stands for minutes, but what does y stand for? Total for the month, right? So y is our total. So rereading the question, says for what number of minutes of long distance usage per month is the rates the same? So when will they be the same? So if it says same somewhere in the problem, chances are it means what is going to be the same? The total, right? So if the totals are going to be the same, then I just set them equal to each other and solve. I just set them equal to each other and solve. So I take my 2 equations, I rewrite them and set them equal to each other. 0.04 x plus 18.95 equals 0.02 x plus 21.95. And then I would solve that problem. Okay? I want to just show you real quick what is really happening here. If this is y and that is y, and they are going to equal the same thing, this is really just a substitution property. Okay, so y is this thing, and I'm plugging it in for that y. Okay, so since y is this, I'm letting it be that, and I get that equation when I do that. All right, so from here, we need to start solving, get all of my variables on one side and all my regular numbers on the other. And what do we need to do first? Subtract 0.02 from both sides. 0.02x, that's subtraction property of equality. So I'm just rewriting my 21.95 on the right, because that's all that's left. I'm going to rewrite my 18.95 because we didn't do anything with it. And now I have 0.02x over here. And next step. Subtract 18.95 from both sides. That works out kind of nice. So all I have left on my left side is 0.02x because those cancel. And this will equal, I think, 3. But okay, good. 3. Now, that was the subtraction property of equality again. What do I need to do now? Division property of equality. So I divide by 0.02. Don't lose your decimal place. Okay. So that goes away. I'm left with just x. 6 divided by 0.02 is what? 150. 150 what? minutes, right? Because X was minutes. So when we hit 150 minutes of long distance calls, both of those plans will be the same. So what does that mean in the real world for us? Is if I look at company A, I'm getting charged 4 cents per minute, but I'm paying $18.95. So everything up to 150 minutes would make this company A cheaper. But everything after 150 minutes would make company B cheaper. So it all depends on how much you plan on using. Any questions?